assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
30.20, we want to find out what the energy is that's required to remove a proton or a neutron from a nitrogen-15 nucleus. And we're going to get different numbers, and we want to explain why that is. So for the proton, we remove a proton, and that's going to create an isotope of carbon. And so, just sort of writing this down, we have our nitrogen, and we're going to represent removing a proton as also taking an electron out, sort of separately to keep all the electrons, to basically accounting for the electrons. We get carbon-14. And so then we calculate the energy needed in a similar way to how we calculate binding energies. And this is why we represent our proton as hydrogen atom, because then we don't have to worry about keeping track of the masses of all of the electrons separately. So mass of our carbon-14 plus the mass of our hydrogen, and the difference of that with the mass of our nitrogen and so this is 10.21 mega electron volts. Now doing the same for a neutron, we just create another isotope of nitrogen. So the number of electrons doesn't change, and we don't have to worry so much about that. We create a neutron, and because the number of protons is the same because it's still nitrogen, all the electrons can stay there. And then it's the same sort of deal here, except now it's nitrogen-14. And this takes slightly more energy, 10.81 mega-electron volts. And now the reason for this is that the proton has an electric charge, and so the repulsion of the other protons in the nucleus helps you basically. You don't have to expend as much energy because the other protons are wanting to get rid of this proton anyway.